Hey, welcome to our next way of graphing. Remember, we're going through a whole bunch of different possible ways of graphing lines, and so because of that, we're going to have a lot of tools in your toolbox. And again, you will probably find one favorite way of doing it. There are going to be benefits of doing certain lines certain ways. So we're going to talk about standard form now, and then this will be the last major way of graphing lines, and we'll spend a little bit of time reviewing, and then we're going to double check your assessment. I'm double checking the volume today, so hopefully this will be a little bit louder than normal, and we will go from there. All right, so standard form. So first of all, can I graph an equation in standard form? That's our essential question. We are going to talk about what standard form is, so if you're asking what the heck is standard form, you'll know that too. Obviously, pause when you need to, so we're not filling up YouTube's servers with lots and lots of dead space. All right, so this is standard form. Ax plus by is equal to c. A, b, and c must all be integers. Integers mean a positive or negative number that is not a fraction or a decimal. And a must be positive. Now again, different books do this, or different people do this different ways. This is the most widely accepted version of it. A must be bigger than 0. That means it's positive, and there are no fractions allowed. Okay, and we'll talk about when we're writing equations of lines after we get done with graphing, we'll talk about the ins and outs of that. But big takeaway, no fractions. So here, actually, even let's highlight it. Big takeaway, no fractions, and it's this form here. And A is positive. In fact, and we'll write that down that way. So A is positive, so no negatives in the front. So methods and steps for doing this, and it's not really so much steps. What you're going to end up doing is that we're going to find the x-intercept. Now the x-intercept, again, if we look at our graph, is going to be like this point right here. Okay, this is our x-intercept. Why? Because that's where we are intercepting the x-axis. The y value here is equal to 0. So what we're going to do, so we're going to plug in 0 for y and solve for x. And we will go ahead and give, I'll have an example after this. Okay. The second step is going to be finding the y-intercept. And this we kind of already know how to do. Or we know what it is. We can't necessarily do it off of this, or you just can't pull it off the equation. And for this one, we're going to plug in 0 for x and solve for y. Because again, here is my y-axis, or my y-intercept, and that's where x equals 0. And then your last step is we're going to connect the intercepts. Now, obviously, I have been a big proponent of graphing at least 3 points. When you do this, the downside, obviously, is if you have 2 points, if you made a mistake, you're not going to see it. And we'll talk about more as we're graphing and reviewing graphing. Pardon me for yawning. By the way, today's secret word is fluffy. Anyway, so we cannot graph using this method when you have decimal or fractional intercepts. Because again, if you have decimals or fractions, you're not going to be exact in terms of your graph. Again, now graphing is an estimation anyway, but there's still some issues with that. Okay? So let's go through and try this. All right, so here's the example. 2x plus 4y is equal to 16. For our x-intercept, remember that is where y equals 0. So what you're going to do, so the x-intercept, enter, if I could write it down. x-intercept. So y equals 0. So I'm going to go 2x plus 4 times 0 is equal to 16. Fast way of doing this just goes away. That's part of the reason why you saw the phrase cover-up method, because you can basically just cover up, in this case, the term with the y. So then 2x is equal to 16, so x equals 8 when we divide through by 2. So my x-intercept over here is going to be 8, comma 0. So 8, 0, label your axes. We're going to make sure that we scale this. Oops, that's a little bit higher. I need to recalibrate this at break. So 8, 0 would be right there. So now we're going to find the y-intercept. For the y-intercept, remember that is when x equals 0. So I'm going to plug in a 0 in for x. And we're going to keep y. And actually, to be perfectly honest, whenever you are doing solving equations, or when you're trying to graph lines, if you're not sure, you can plug values in. Now, it's not always going to be the easiest thing, because occasionally when we get to more complicated graphs, it's going to be a little bit more involved. But you're on a test, you've got the time, you know, worst case, plug in points. So that's going to be my y-intercept, 0, 4. So go up to 0, 4. And again, you know, let's actually label these out to be safe. We're going to draw our line. So you get out your straight edge. It's a little bit bigger than I want, but that's all right. Boom. There you go. Oops, I don't want to sound. I'm just going to make it a little bit thinner. Maybe not. Nope. All right. Anyway. Pardon me. So there's that. X-intercept, y-intercept, connect the dots. Again, remember, pause as you need to. So here, x plus y equals 4. So for my x-intercept, where y equals 0, I get x plus 0 equals 4. So x is going to equal 4. So for my x-intercept, I get the point 4, 0. For my y-intercept, that's where x is equal to 0. So I get 0. How's that for a save? So again, go back to the original equation. 0 plus y is equal to 4. And in this case, since the coefficients are 1, we actually just get similar points. And that's not always going to happen. This is a special case. And we get our line. And there you go. Example 3. This will actually look very, very similar in some ways, but you got to be careful because you see subtractions. Let's go over here, x-intercept, where y equals 0. And again, the more that you write that down, x-intercept where y equals 0, the more it's going to get ingrained in your head. Because again, remember, what ends up happening is that if you write stuff down, and actually if you say it as you do it, it'll imprint itself on your memory much faster than just simply watching it. Writing it down is going to be much more helpful because you're using more senses. If you're just watching it, because when you're writing it down, you're actually also watching it and writing it at the same time. So when the y-intercept where x equals 0, I'm going to get x minus, or 0 minus y is equal to 2. So now in this case, I get the opposite of y is equal to 2. So what is, if the opposite of y is equal to 2, what is y equal to? You can either divide through by -1, if you wish, or you can just kind of think your way through it and saying, well, okay, the opposite, what number is the opposite of -2? Or 2, that'd be -2. So in this case here, when I plot these, I get 2, 0. And then here, I get 0, -2. Draw our line. Woo! Oh, you know what I didn't do on the last one? We'll do it right now. Forgot to label these. 2, 0, 0, -2. If you really want to win bonus points, label your line. And when I say bonus points, it's like favorite student points, not actual extra credit, but it's one of those things you really should do to show yourself to be a very intelligent person. Example 4. I'm just going to walk through this. You can go ahead and do it. I would pause it right now, actually work through it, and then come back to it. So again, the intercepts are places where the opposite variable is equal to 0. So your y-intercept is going to be where x equals 0. So I get 2 times 0 minus 4y is equal to 8. That goes away. So my y-intercept is at 0, -2. My x-intercept's at 4, 0. That trended a little high. Better. And then we will draw the line. Wow, that's thinner than I wanted. Obviously, with a straight edge, you can line things up a little bit better than I can with a computer. So, you know what, let's do this. We'll make it perfect. And then we'll move it. There we go. Okay, and as I said, being the nice mathematicians that you are, I'll write down the equation. Man, I apologize for all the yawns. And there you go. Again, pause as you need to, replay as you need to. Okay, another one. Hit pause. And let's go. X-intercept, so where y equals 0. So, so your x-intercept is going to be a 2, 0. Also remember, on YouTube, you can also slow things down. So if I'm writing too fast or talking too fast, you can just slow it down. And things will move slower. So that goes away. So I have 4y is equal to 16. Some of you may have started to see a pattern with the slope. Between the coefficients up here. Between what's going on there and what's going on down here. So take a look at that. And we compare it to what's going on here. And what's happening with that line back on example 4. something to think about. All right, last one, example 6. Pause as you need to, my friends. That's what I should be doing with the recording while I'm yawning, I suppose. Do, 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 do. You can't tell, but I'm lip syncing to a song right now. No. So your x-intercept is 2, 0. Change up some colors a little bit here. Y-intercept, where x is equal to 0. So I get 3 times 0 minus 3y is equal to 6. So negative 3y is going to equal 6. Because again, remember, this goes away. I should have crossed this off up here. So did what you think about follow suit? Did what was happening up here hold true down here? Something to think about. Oh, yep, I was right. That was it. So that is the basics of graphing in standard form. Again, you could solve for y. You could, try to do point slope. But a little bit faster because you don't have to spend all the time going through and solving out for y first and then trying to, plot out points. So that's a good way to double check it. Anyway, I will see you next time. Talk to you soon. And remember, the secret word is fluffy.